In Algebra 2, Section 4.7, we're dealing with transformations of quadratic graphs. So we were dealing before in a chapter before on how things shift left or right, up and down, and then if they get big, if the u of a parabola gets bigger or smaller. So if you remember, this is our original graph. It goes through 0, 0. So transformation is if I shift this over and then up a certain amount, and then the u gets bigger or smaller. This is what this section is going to tell us. So it breaks us down. It's a little difficult. Some of you guys had difficult in that chapter, but it's a little difficult in the sense that we need to first put things in what is called vertex form. Okay, so you know how to find the vertex of a graph by putting in by doing the negative b over 2a, right? And then after you do that, then you plug in that answer into the equation. So remember finding the vertex of a quadratic equation. Now in this case, if we put it into what is called a vertex form, then if we make the equation look like this, then the h, right, is our x of our vertex, and the k is our y of the vertex. So it helps us identify the vertex right away, and this a tells us more information whether it opens up or down, and we'll know more in the next section. But for this part, we're just going to focus on the vertex form. So here's an example. So here's our basic equation, and we want to put this into a vertex form. So what they did first is they're going to take the first two terms and make it into a perfect square. So you remember how we were trying to solve a quadratic equation by perfecting the square so that we have a bubble square. That's what we need to do here. Okay? The only difference is whatever we did to one side, we have to do to the other. Now, in this case, we're not going to do, we want to do it on the same side because we don't want to add anything to the y. And I can do that by adding nothing. Okay, sounds weird, I know. But what I mean is, if I add 0 to an equation, it's still balanced. So that means if I need to perfect the square by adding 4, then as long as I add 4 but then subtract 4 at the end, the 4 and 4 cancel each other out, right? So we're going to take the first two terms and make it into a perfect square. So let's focus it one step at a time. I'm going to take this and just focus on this. So I'm not going to focus on this because I want to make this into the parentheses squared, okay? And I'm going to take, just like in the perfect square, I'm going to take this b and I'm going to divide it by 2 and then square it. So b equals negative 2. I'm going to divide by 2 and then I'm going to square it. So negative 1 squared gives me positive 1, right? Then I'm going to take positive 1 and put it in here. The whole reason I want to do that is so this parentheses ends up looking x minus 1 squared, right? So this should be review over perfecting the square in that one section that we did. The only difference is I could, if I add 1 here, I have to add 1 on this side too. What I do to one side, I have to do to the other. But instead of adding it, I'm just going to automatically bring it over by subtracting it. This means that if I add 1 to here and subtract 1, this equals 0. So that's why I have to subtract 1. I can add whatever I want to here as long as I subtract that same number from the end so that I can keep the equation balanced. That's what that's for. So once this is factored, then I go ahead and they match. So my a, because there's no number, is 1. So that means it's a positive 1. And I'll tell you what that means in a little bit. And the vertex is negative 1. Well, sorry, 1. See how this is negative? So it's 1, 3. So if I were to graph this, I know the vertex is 1, 3. Okay? It's a new step, but this might be quicker than doing the negative b over 2a, is to put it in vertex form. So go ahead and pause this, write it down. We're going to try an example together to see maybe if it's more clear. Sorry. So pause it, write it down. So here's our equation. It's asking us to put into vertex form y equals x squared plus 4x. So look at your notes and let's see if we can take it one step at a time. So y equals 2x squared plus 4x plus 1. Okay, this example problem is a little bit different from the steps that we took here. The main difference is, you see how x squared has a number here, and in this one x doesn't have a number in front of it? So if a number doesn't have in front of it, I'm going to do all these steps here. But because there is a number in front of it, I first need to take that number out, because the perfecting the square strategy only works if I first, if the x squared is a 1, right, in front of it. And that's easy. All I need to do is take out by dividing these. So I'm only going to focus on these two. So instead of this, I'm going to have 2x squared plus 2x parentheses plus 1, right? I haven't changed anything, because when I take this 2 and I put it back in, I still get 2x squared plus 4. But now I can focus on this, and I can do the perfecting the square situation. I can start with step 1. So this is our pre-step. Then I can do our step. Our first step is to take this, and on my b is 2, right? So I'm going to go 2 divided by 2 equals, 2 divided by 2 is 1 squared. Sorry, 1, right? So, and then I'm going to square it, which gives me still 1. So I'm going to take b divided by 2 and then square it. So that's what I did here. B divided by 2 squared, right? So my next step is then asking me to take my step from number 1, okay, and put it into my equation. So y equals 2x squared plus 2x plus 1, right? And this is plus 1, and then I do minus 1. So I have this right here. Here's my problem, my dilemma. I need this in the parentheses, but if I put a 1 in the parentheses here, and I multiply this out, right? This 1 actually represents 2, because 2 times 1 is 2. And if I've multiplied 2, right, and I've only subtracted 1, then I've changed the balance of the equation. Now I can do one of two things. I can then divide this, right, by 2. I can divide this by 2 so that this represents, or if I'm multiplying this by 2, then I simply need to subtract 2. So one more time, the reason why I add 1 here but subtract here is that this 1 actually represents 2, okay? 1 times 2 actually represents 2, right? So because of that, then what I need to do is then minus 2, because when I multiply this out, I still need to get this original function. So if I multiply this out and combine like terms, I still need to get this original function. That's how I know I've kept it balanced. So if ever you're not sure, just multiply it back out if you think you did something wrong. But because I subtract 2 and this multiplies, they'll end up canceling out and I'll have my original. So it's all about keeping the equation balanced. So once I do that, then step 3, wants us to factor it. Since this is already a perfect square, this is turning into x plus, and it's always half of b. When I do this whole method of perfecting the square, then I've manipulated it, so this is x plus half of b, so x plus 1. And if I'm not sure, I can check it out. If I multiply these out to x plus 1, and I do the whole, I would get x squared plus 2x plus 1. Right? It'd be x squared plus 1x plus 1x plus 1. And then everything else I'm going to bring down. So equals 2 plus 1 minus 2 is minus 1. Okay? So basically what this is saying, if I look at my original equation right here, my vertex, okay, now because this is a negative, right, and this is a positive, in order for me to make positive is that this had to be minus -1. So this is a -1, it's the opposite, comma 1, comma -1 right here, because this is a plus k. So we take k as it is, right? But h is the opposite because I have to end up with a negative here. And since I end up with a positive, that means I have a negative on a negative. So my vertex is -1, -1, and my A is 2. And I'll explain the need for the A in a minute. So hopefully that made some sense. We're going to actually graph this now. So it's important for you to write this because we're going to graph this equation. And I'm going to explain to you guys the transformation using the vertex form. So pause it, write this down, and we're going to carry it over to our last page. Okay, so when we're using transformations using the vertex form, our H is the horizontal translation, which basically moves left and right, how much it tells us to move left and right. Our K is how much it tells us to move up and down. And then our A tells us, does it open up or open down? So if I'm here, and here's if this one is the same equation from number 2. So our vertex is -1, comma -1, and our A is 2, right? So this means that if I took this parent graph, I would move the vertex back 1 and down 1, right? And A tells us that it's positive, so it opens up. So I'm going to take our vertex, I'm going to put -1 down, right? The horizontal, yes. Okay, so this is our vertex. Now, I know that it opens up, but I don't know how wide. Now, it tells me that I moved 2, but what I'm going to do is I'm just going to first find, what am I going to do? I'm going to test a point. So let's say this is 1 away, so I'm going to test 0. See how 0 is not on the, as long as it's not on the vertex, I'm going to test the point. So I'm going to test x, or I'm going to plug in x equals 0. Okay? So y equals 2 times 0 squared plus 4 times 0 plus 1. 2 times 0 is 0. Plus times 2 is 0 plus 0 plus 1. This is 0 is 1. So our point here is 0, comma 1. So another point we have is 0, comma 1. Okay? Here's my axis of symmetry. So if this is 1 away, then it's also 1 away here. So from there, done. So the vertex form can also help me graph. I just need to check one point. I can test any point, and it mirrors on the axis of symmetry. And since I know the vertex, I know that the x is my axis of symmetry. So it's a little bit of review from what you did last time. You just don't have to do those big tables because when you do the vertex form, you're already halfway there. Okay? So hopefully this wasn't too long, but it might have been. But anyways, go ahead and try page 278, numbers 2 and 6, 278, numbers 2 and 6, and I will see you in class.